Yes. Hello, my dear students. My name is Lakshmi Narayana. We are going to discuss about the numerical problems on ionic product of water. So here one of the problem is there. So before going to that problem, so we have to discuss about the ionic product of water and what formulas are involving in numerical problems. So first one, for example, ionic product of water that we can represent with a Kw, that is H2O ionization takes place, then it forms H plus OH minus ions, then Ka ionization constant of water when it is present in the equilibrium, equals to H plus ion concentration into OH minus ion concentration divided by H2O concentration, like this. Then K equilibrium H2O concentration equals to H plus ion concentration into OH minus ion concentration. Right? So equilibrium constant or ionization constant of water, we call it is ionization constant of water into concentration of H2O, we call it is Kw. Kw equals to H plus ion concentration into OH minus ion concentration. So that is why we can also take it is Keq, that means ionization constant of water into H2O equals to Kw also we can write. So these formulas are mainly used in the numerical problems of ionic product of water. Then including with that, then here H plus ion concentration is equals to OH minus ion concentration. So it is at 25 degrees Celsius. Then in case H plus ion concentration, it is equals to 1 into 10 to the power of minus 7. Then OH minus ion concentration, it is equals to 1 into 10 to the power of minus 7. Then Kw equals to 1 into 10 to the power of minus 14 molarity square, because here molarity and here molarity. So H plus ion concentration and OH minus ion concentration, both if we take so molarity, then molarity into molarity square you can get. This is the formula for the calculation of ionic product of water. Now we are going to discuss about the problem, numerical problem. So what is this that we have to discuss now? Look at once. The problem is the H plus ion concentration of solution is 4 into 10 to the power of minus 5 molarity. Then the OH minus ion concentration of the same solution is, they are asking a question to you. Then here, so if you observe Kw equals to H plus ion concentration into OH minus ion concentration. So you must be know the Kw value 1 into 10 to the power of minus 20, 1 into 10 to the power of minus 14 meter square at 25 degrees Celsius or room temperature. So here that is why we are taking it is 10 to the power of minus 14 equals to H plus ion concentration is given, that is 4 into 10 to the power of minus 5 into OH minus ion concentration. What they are asking in the question, OH minus ion concentration of the same solution is. So what you have to take, OH minus ion concentration equals to Kw divided by nothing but Kw is what? So 10 to the power of minus 14 divided by 4 into 10 to the power of minus 5. Then here 1 by 4. So actually here nothing is, then is what? 1 by 4, 0.25 into 10 to the power of minus 5, if we send up 10 to the power of minus 9. Then this point when it is shifted to here, so 2.5 into 10 to the power of minus 9. 2.5 into 10 to the power of minus 10 molarity can get. So 2.5 into 10 to the power of minus 10 molarity is the answer. That is fourth option. Yes, understand? Yes, I hope it is understand. Please note it. We'll discuss the next problem. Yes, look at the next question. The OH minus ion concentration of 0.05 molarity of H2SO4 is what? So here actually when the molarity is there, that concentration you have to take, you must be take in the normality only, in the pH values. So that is why here why you are taking the normality actually, because this basicity of this acid is 2. So here normality, if you want to convert, the normality equals to molarity into the basicity, or n factor we call, n factor. So n factor for this acid is, so that means number of replaceable hydrogen atoms. So here normality equals to 0.005 into, so 2, in case if you multiply with 0.01 normality can get. So nothing but, so 10 to the power of minus 2 normality. This is the concentration of H plus ions concentration it is. Normality nothing but what? H plus ion concentration of this particular acid. For that particular acid they are asking OH minus ion concentration. So what I told, OH minus ion concentration is equals to Kw divided by H plus ion concentration. So Kw value what is that? 10 to the power of minus 14. It is at room temperature, divided by 10 to the power of minus 2. Then if you go up, when it is sent up, then you can get it is 10 to the power of minus 12 molarity. So that is the formula, 10 to the power of minus 12 molarity. Yes, note it. Yes, look at the next question. At 25 degrees Celsius, OH minus ion concentration of basic solution is 6.75 into 10 to the power of minus 3 meters. Sorry, molarity. Then the value of Kw is, so 6.75 into 10 to the power of minus 3 molarity, then the value of Kw is, they are asking a question. Sir, at 25 degrees Celsius, at 25 degrees Celsius, Kw value always 1 into 10 to the power of minus 14 molarity square. So that is the fourth option, 10 to the power of minus 14 molarity square. So note it, at 25 degrees Celsius always the same value, it is a fixed value. Yes, look at the next problem. At a certain temperature, H plus ion concentration of water is 4 into 10 to the power of minus 7 molarity. Then the value of Kw at the same temperature, at a certain temperature, not mentioned at 25 degrees Celsius or room temperature or something. At a certain temperature they are mentioned. So whatever it may be, H plus ion concentration of water, it is equals to OH minus ion concentration at whatever the temperature is there. So H plus ion concentration how much is given? That is 4 into 10 to the power of minus 7 molarity. So that is equals to OH minus ion concentration also. Then Kw equals to H plus ion concentration into OH minus ion concentration, we know that. So H plus ion concentration what is there? 4 into 10 to the power of minus 7 molarity into 4 into 10 to the power of minus 7 molarity, right? So then 16 into 10 to the power of minus 14 molarity square. Then this point when it is shifted to here, so 1.6 into 10 to the power of minus 13 molarity square. So 1.6 into 10 to the power of minus 13 molarity square is the answer. Yes, I hope it is understand. Just note it. These all the values are, these all the problems are belongs to Kw, ionic product of water. Yes, look at the next question. The ionic product of water is 10 to the power of minus 14. The H plus ion concentration in 0.1 molarity of HCl solution is, that is given H plus ion concentration. They are asking H plus ion concentration. So actually it is OH minus ion concentration. So Kw it is equal to 10 to the power of minus 14. then NaOH, nothing but you have to take OH minus ion concentration, that is equals to 0.1 into 10 to the power 0.1. We can also take it is 10 to the power of minus 1 molarity, right? So Kw equals to H plus ion concentration into OH minus ion concentration, right? So OH minus ion concentration you have to substitute, Kw value you have to substitute, then what you can get? H plus ion concentration. H plus ion concentration equals to, so Kw divided by OH minus ion concentration. So Kw 10 to the power of minus 14, 10 to the power of minus 14 divided by, so 10 to the power of minus 1, then you can get it is 10 to the power of minus 13 molarity. This is what? H plus ion concentration. So 10 to the power of minus 13 is the answer. Yes, I hope it is understand. Note it. Yes, look at this question. It is somewhat different question when comparative to previous questions. So, dear students, the number of H3O plus ions present in 10 ml of water at 25 degrees Celsius is. At 25 degrees Celsius, H plus ion concentration or H3O plus ion concentration, it is equals to 10 to the power of minus 7. We know that. That is known concentration of H plus ion. So here number of, not number of, then concentration if you want to find out. Concentration of H3O plus ions, H3O plus ions in water equals to, actually for 1 liter we can take it is 10 to the power of minus 7, it is known concentration, into, but they are asking here for the 10 ml, so that is why 10 ml divided by, so 1000. How we are taken, using which formula we are used this, so observe it, that is number of moles into volume in milliliters divided by 1000. So if you use that number of moles at for 1 molarity, in case if we take it is 10 to the power of minus 7 for known concentration at 25 degrees Celsius into volume 10 ml divided by 1000 if you take, then here, so 0 0 cancel, 1 by 100 nothing but 10 to the power of minus 2. So 10 to the power of minus 7 into 10 to the power of minus 2, we can get 10 to the power of minus 9. It is the concentration. In this particular concentration, how many number of ions are present? So you have to multiply, actually for 1 mole Avogadro number. So just multiply with Avogadro number, you can get the value. So number of H3O plus ions equals to molarity, number of moles, that is 10 to the power of minus 9 into 6.023 into 10 to the power of 23, right? So here 6.023 into 10 to the power of 23, then minus 9, 10 to the power of minus 9 if you do, then if you subtract 9, you can get 10 to the power of 14 plus 14, 10 to the power of plus 14. So 6.023 into 10 to the power of 14 is the value of this. Yes, understand? So here number of H3O plus ions equals to moles, number of moles into Avogadro number you have to take. Yes, note it. Yes, look at the next question. The dissociation constant of water at 10 degrees Celsius is, at 10 degrees Celsius is, temperature not at 25 degrees Celsius, 10 degrees Celsius they are given, 5.31 into 10 to the power of minus 17. The ionic product of water is, they are given the options like this. So at that time, sir, here one of the relation I told, that is equilibrium constant of water, nothing but dissociation constant of water into H2O concentration equals to Kw, ionic product of water. Ionic product of water. Sir, here equilibrium constant K, then H2O concentration, both are given. Sir, if you observe in this, what they are given, dissociation constant of water is given already, that is, then we should know that for 1 liter of water, number of moles of water, it is 55.55. You have to take it as, so 55.55, it is a fixed value, number of moles. How it is? Number of moles equals to, so given weight divided by molecular weight, nothing but, so 1000 for 1 liter, 1000 grams divided by 18, you can get 55.55 like this. Okay, so the concentration of this, the concentration of H2O, 55.55. Now what we have to find out? Ionic product of water we have to find out. So Kw equals to, then equilibrium concentration, nothing but ionization dissociation constant of water, so that is 5.31 into 10 to the power of minus 17 into H2O, that is what, 55.55. then if you multiply with both, then you can get it is 0.295 into 10 to the power of minus 14 mole square liter inverse 2. So this relation is very important, remember it. So that is equilibrium constant, we call it is dissociation constant of water also, into H2O concentration equals to ionic product of water. Yes, note it. Yes, look at the next question. So that is ionic product of water at 60 degrees Celsius is 9.55 into 10 to the power of minus 14 mole square liter inverse 2. The dissociation constant of water at the same temperature is, so again the same relation, that is ionization constant of water into H2O concentration equals to, so that is Kw. What they are given, what we have to calculate? Sir, ionic product of water is given, Kw is given. Then what you have to calculate? Dissociation constant K you have to find out. So K equals to Kw divided by H2O concentration. Sir, H2O concentration for 1 liter it is fixed, that is 55.55. Okay, then Kw value, what is given Kw value? 9.55 into 10 to the power of minus 14 divided by then 55.55. If you do the answer, you can get it is 1.72 into 10 to the power of minus 15. That is the answer. Understand all of you? Yes, note it. Yes, my dear students, up to now we have discussed about the ionic product of water. Ionic product of water Kw into H2O concentration equals to, sorry, ionization constant at equilibrium position into concentration of H2O equals to Kw. Then Kw equals to H plus ion concentration into OH minus ion concentration. Then here H plus ion concentration is equals to OH minus ion concentration for water. Then H2O concentration for 1 liter, the number of moles you have to take it is 55.55 moles per liter. These are the concentration. Based on these formulas and the values, so we are done some of the problems based on the equilibrium constant. Then ionic product of water. So just one of the problem I given as a homework to you people. Then do it. Then tell me what is the correct answer. Do it in the comment section. Then which is the correct answer, just mention as a comment. Thank you. We will do next pH problems.